In this video, we will measure the performance of an operation on parallel and sequential stream. So let's create a new class, new, and then Java class, and the class name is stream performance example. Let's create a public static wideband, and also we'll create two static methods, one for the sequential processing and other one for the parallel processing. So public static int sum of sequential stream, and here we are returning int stream dot range close 0 to 50,000 dot sum, and the other method is public static int parallel sum of parallel stream and return int stream dot range close 0 to 50,000 dot parallel dot sum. So if you look at these two methods, they look exactly like a supplier. So supplier basically just provides input, it does not require any input. So they are exactly like supplier. So let's create another method, and this method is public long measure performance, and here the input is supplier, and as these method will return integer, so input is integer, or the type is integer, and then supplier and int number of times. And we'll be looping through integer I is equal to 0, I is less than number of times, and I plus plus, and supplier dot get. Also we'll be measuring the performance of this loop, so let's have long start time is equal to system dot current time millisecond, and at the end time or return system dot current time millisecond minus start time. So it will return the amount of time it will take to go through this loop. So here this method will get a supplier, and supplier will be sum of sequential stream and sum of parallel stream, because they don't require an input and it's just an output. And afterwards we are calling supplier.get, so it will invoke these two methods. So we'll be passing sum of sequential stream to measure performance and sum of parallel stream to the measure performance, and it will run them 20 times, or the number of times which will be providing, and afterwards it will basically print the start time. It will return the amount of time it basically took to execute that operation, and here in the public static void main will be printing it up. So let's say integer loop is equal to 20, so we want to run this 20 times. So and long result is equal to measure performance. Here we have to declare this method static, and measure performance, and in this case supplier is stream processing example, and then you can see that it basically giving me the option. So this is first one we'll select is a sequential stream, and the second parameter is loop. And let's print out the result. So sum of time taken to process sum in sequential plus result plus in millisecond. Now result is equal to measure performance for parallel stream, and supplier in this case is stream performance dot sum parallel stream, and loop is a number of times it is taken, number of times it will loop through, and then run the method, and again print out time taken to process sum in parallel plus result plus in milliseconds. So let's go through this program again. So inside the main we are calling measure performance. It is with the number of times it has to loop through, and this measure performance will get a supplier, and then supplier in this case is either the sequential sum of sequential numbers, or calculating sum of the sequential numbers, or calculating sum of the parallel numbers, and then it will loop through from I is equal to 0 to, in this case, loop 20 times, and then at the end it will return the time it took to run this operation, and afterwards we are printing out the time taken to process sum in sequential and time is taken to process sum in parallel. Now let's run this program. So you can see that time taken to process sum in sequential is 14 milliseconds, and time taken to process sum in parallel is 8 milliseconds. So with running in parallel, the time is approximately reduced by 50%. It basically depends on the process on the machine and the system you are running in, and you will see different performance while running in parallel or while running in sequential.